The first 3 weeks of the eruption here in Hawaii, crazy things would happen in the middle of the night. A new fissure would open up and it would threaten a new neighborhood. Thousands of people are evacuated from their homes. I started the Hawaii Tracker Facebook group to help people understand what's going on and get their questions answered.
Hey, how's it going? We're live. This is Fissure 20.
We had hundreds of people all throughout the neighborhoods sending in videos, articles, and images. We spend a lot of time making sure the accurate information gets out.
This is live. There's still lava moving.
They weren't just sharing a story, they were helping their neighbor. If a family was being evacuated, my group would just jump in and help out. So it was huge. They were watching out for each other.
Hello everybody, thank you for coming. Thank you for the support from everybody.
As we go through this, we're growing closer together as a community. When tragedies like this strike, you really realize how much you need each other.
Aloha everyone, I'm geologist Philip Ong, here with Mr. Dane DuPont of Hawaii Tracker, bringing us another Hawaiian Volcano Tracker update. And today, Friday, August 19th, 2022, we're going to talk about what's happening in Kilauea, much of the same, to be honest. Still cool to look at. We'll check back in on Mauna Loa, which had its earthquake swarm a few weeks ago, and it's still adjusting, we'll say. But nothing major happening there either. And we'll cover the public meeting that happened at Pohoiki yesterday a little bit. We're going to have more coverage of that upcoming as well, but we'll have more of an instant reaction today. And finally, we're going to touch base with the USGS coverage of Samoa. The two volcanoes in Samoa have had alert levels raised today, as there is earthquakes ongoing over there. Still nothing super alarming yet, but enough to warrant deploying a team out there. So we'll cover all of that as well. Dane, would you like to say anything here to start us off?
Yeah, I'm interested to hear more about the American Samoa stuff, since I was only briefly able to touch upon it last week. The volcano notices were coming out, or the information briefs were just beginning to come out, type of thing. And now we have a week more, and we have these volcano notices that got put out today, 2 of them, right? So we get to go in a little bit deeper on those things and actually figure out kind of what's going on. And also they were able to figure out where the earthquakes were exactly coming from, which is, as of last week, I didn't know.
Yeah, kind of.
So, it'll be exciting.
Yeah, so today's Volcano Watch is about Samoa, so that helps a lot. They did install a second seismometer, and that gives us a little more data, but it's still not really enough. So they're still sending more people out there, and we'll summarize what they've said so far. We are not Samoa experts, so I'll say that off the top. We're just gonna try to summarize what the USGS is putting out, so that everyone can synthesize and keep track of a developing story over there. So all of that said, we can probably get started here by talking about Kilauea first, as usual. So I'll transition to our opening photograph here as a capture that Dane caught from one of these dawn images from the KW camera, showing the glow of the lava lake with the fumes being illuminated in that kind of pinkish, reddish, orange color in there. And so pretty cool. That's our image of the week here. But let's get into some of the meat of what's been happening. So from that same camera, here's the KW camera, the last week time-lapse. So we flip through day and night, and of course we have our persistent lava lake still active in the middle. What you might notice is you're seeing spots of flashes of color, in the nighttime views especially, coming up around a perimeter. So you see these ooze-up flows that occur down here in this area, which is the west. Over here in the north, there's one just happening as we speak in this northwest quadrant, but there's also one that pops up over here in the east and the northeast. So it's really all around. And that's, as we've discussed before, because this crusted over lava lake, the center of it is more buoyant and keeps getting lifted and rising, floating upwards. And along the perimeter, it creates a weakness, and the lava can ooze up through those weaknesses around, and then it floods those areas. And that's what we're seeing here. There have been some weeks where we've had lots of those and some weeks where we've had less. It's been a while since we had quite so many. It's a little harder to tell all of them now because the crater is so big, and you have to be looking at the right spot from the right camera. And so that's why I like to use this KW camera as our first orientation here, because we're capturing that full width of the view. Not as easy to see in the daytime, of course. That's why we like to see the thermal camera as well. But you can see the activity is, as I described, pretty typical. In the center, still glow from the west vent area right in here. And otherwise, ooze-up flows are really the story all around for this past week. So the KW camera, let's check in on it now. Let's see if this will load for me. All right, so there it is from about an hour ago, how current view actually looks. And it's not quite dark enough here in these still summer months to get the view at this time of our broadcast, but I'll try to reload it here and see if it pops up any different. Still pretty similar. So let's transition to the F1 thermal camera. And here is the last week time-lapse. And as usual, our persistent lava lake, and we're going to catch some of these ooze-up flows around the perimeter here. So let's see if I can get this to come up a little higher on this. There we go. So you can actually see the bottom of it here, because it's really in this bottom part right in here where we see this big ooze-up flows. You just saw the one flash up that's ongoing now. I'll get to that in a second. You can see a little bit of the ones in the northeast and the east, and really this one front and center in the west was the really most photogenic, we'll say, right? That's been lasted several days and was still oozing as recently as a couple of days ago. So that's the pattern from the F1 camera. Here is the last 24 hours from F1, focusing a little bit more on what's going on right now, which is this northwestern quadrant breakout right here. And we've said this before, but it's really impressive how big these areas are, right? You can see compared to the size of the persistent lake, it grows larger, twice as large, 3 times as large as that pretty quickly, and then disappears, hardens over, crests over. So the heat disappears from the camera after not too much time, actually. So all that makes for good viewing, because these big ooze-up flows are an extra thing to see. I mean, the lava lake is enough to look at on its own, but then if there's other big flows around a perimeter, that makes it even better. So zooming into the V1 camera to get a closer look at what the actual lake is doing, the persistent lake, the most reliable target for viewing, and the most persistently open surface in the volcano for, what is it now, 10 months or so? I guess 11 months. Yeah. So 10 and a half, 11 months. And what you really see here is a lot of flashing, and you don't see a whole lot of dramatic change anywhere else, right? Lava circulating, the camera obviously moves. But as far as lava level, which we typically look at with this, you really don't see a whole lot of change. You see these little fluctuations in the range of the camera, but nothing major. There's no major drop, no major rise. It's varying, certainly, but not in a very noticeable way that you can see the migration. So reliable, and that southeast pit is still, whoop, it moved on me. There it is, that southeast pit up here is still overturning, so the lava is still moving through that little tunnel under this isthmus and filling that area and then draining out from there underneath the crust further on. And the same thing still happening over here in the east and over here in the northeast, where you have these spattering sinks, right? And good places to look at if you're coming in for viewing. So that's the V1, and let's like we did the other ones. Let's check in at a more current view. So there it is today. Pretty similar, still no major changes going on there. This new camera view I like because we can see more of what's happening up here in this part of the weak rim of that crater, right? We talked about how there's that buoyant crust, and the edge of it is more or less and kind of in there. It might come more like this and wrap around-ish, something like that. But you see a little bit of the fume, and in the nighttime views, you can actually see some glow coming from this area as well. Glow coming from here, and glow comes from this west vent complex over here as well. So interesting stuff to see there. Okay, so let me switch now from our weekly summary to our lava viewing report. And we're going to do this a little different and more quickly today, just because I haven't had as much time. We were at the meeting yesterday, as you all are likely aware. But here is our park orientation map, and our viewing areas are still the same. Uikahuna, Kilauea Overlook in the north, Kupina'ipale, aka Waldron's Ledge, over here in the east, and Kanakako'i over here in the south. So all of that is unchanged. What I'll do today is I'll show you guys a couple webcam views as proxies. So we'll start off with a B1 camera, which is looking from the east. This is not too dissimilar a view of what you might get. It's not exactly the view you'd get, but it's similar in a perspective you might get from Kupina'ipale or from Kanakako'i, in a sense where you see the lava lake as a smaller feature, as just one small part of that overall crusted over crater floor. So the angle is a little bit different. The hornitos maybe aren't quite as visible in the same orientation alignment, but it's a similar kind of view. So that's why you really zoom in and bring those binoculars or telephoto lenses or those kind of things if you want to get those close-in spatter views. Right? So that's the B1, and let's check in on the current view of that one. Looking pretty similar right there once again. And we'll move on to finally the S1 camera. So this is a little bit different perspective, but it's focusing more on a lake, which is a little bit more what you're interested in, likely, if you're coming to see the activity at the national park. And steady, as we've seen from all the other angles, there's really not a whole lot of detail to dig into on this week. Interesting alternate views of these, especially this most recent breakout that's happening in the northeast. You see the in-between one, the first one that was big from the other angle, and the ongoing current one up here in this northwest back behind it. Also the glowing spots. You see several of those glowing spots. So interesting to check out that activity and keep track of it as well. So that's our S1, and current view pretty much the same as well. All right, so of course, make sure you check the National Park website. It'll give you current openings, closures, eruption viewing. By the way, the Nahuku lava tube in a national park has reopened after being deemed safe after a certain amount of monitoring. I don't think I have an announcement up on the page here, but that did happen this week. So if you're visiting a park, then that's good news to see the lava tube reopen as well. All right, so that's their viewing report, and we'll transition from that into our hazards. And so from this page, if you scroll down on the national park page, you can come down here and look at the weather conditions, gas conditions as well. And so what we'll look at there is the gas conditions next. Here is the national park website. On the gas, you can see the wind direction. Blows the plume to the southwest here from its source. So almost all the viewing areas are typically upwind, and they're all in a green today. And if we scroll back, everything's been in the green, really, at all the sides today. Earlier in the week, we did have a little bit of a switch of the winds. That does happen. But the combination of both having a low SO2 emission value reported. We'll talk about that shortly as well. It's down around 1,000 tons per day. This measurement's putting in 1156 tons per day as its input, and you can see the amount of VOG forecast from the VOG mapping project at the University of Hawaii is not as widespread as it sometimes is when we show you guys this forecast. Certainly still affecting the South Hawaii area, right, and up into the national park as well, but a little bit less visible. We still see a little bit in South Kona and upper slopes, a little bit coming over here into the lower Kona area, but it's very transient compared to before. So there still may be effects, but it is at a lower level. And if we check our citizen science purple air page, you can see similar kind of patterns, mostly green, but some of these areas you can click on them and you do see that they do jump into the yellow at certain times during the past week there. I can put on Pahala. Pahala's got one of these typical weird spikes that will actually jump up into this real maroon, really high values, right? So it's not quite clear if there's something else like a local fires with smoke and something like that could be happening too. Right, small kind of stuff. Otherwise, you see variations. It goes into the yellow as well from the volcano. So the air is relatively clear, but that is still the main hazard that we have, and the eruption has not really changed in its threat. Otherwise, the gas is still hazardous, of course, and we'll keep reporting on it for that reason. So I showed you this picture a little earlier, right? And this is one from the camera on the 15th. And what I wanted to point out here is there's a second one from the day before, and there it is. Two amazing dawn shots captured by the camera and picked out by Dane, but I thought it was really cool to see that in this one on the 14th. The wind is clearly coming from that direction. You can see the plume blowing off over here. And if we go to the next day, you can clearly see it's blowing off over here. And so besides the prettiness of the picture, you can really see the variability of the wind direction there. And of course, if you're in the viewing areas in the park, by the steam vents or Kahuna or the visitor center, all that stuff is this direction, right? So you can imagine that these early morning, weakest winds times is when this is most likely, but that's also time for viewing. So just keep that in mind, that is possible. Check the park website. All right, so we will switch from our hazards to our media of the week. There has not been a lot from the USGS because they are deploying to Samoa and keeping track of the other stuff, but we are going to feature today a tweet from Cosme 648333127 on Twitter, right? And he's taking Copernicus Sentinel-2 satellite data from August 10th and rendering an image. So here is an image from the satellite showing a glow from the persistent lava lake and ooze up flows 1, 2, 3, 4 on that single day. So that's our featured image here. Pretty cool to see that up from space. Good viewing from up there too, apparently. All right, so from that, we will switch to our monitoring data. So let's do that. Let's click over here to monitoring and switch our title and talk about lava depth. So here's lava depth for the last week on the top and summit tilt on the bottom. And as usual, we see the very typical mirroring of patterns. You don't really see a whole lot of obvious delay or anything right now. It's hard to tell on this scale exactly. But you see this pretty tight correlation there, right? The tilt goes down, so does lava level. Goes up, so does the lava level. And within the last week, you can see the range of this has been, more or less 1.5 meters from top to bottom. Right? It really takes scrolling back to look at the last month to really get it in perspective to what was happening before. If you've been following us for a while, it's a better context here. So we were just zooming into this 1.5 meter variation, and you can see that about a month ago, we were having variations that were more in the order of 4 meters up and down when we had as much bigger deflation-inflation events. So big deflation-inflation events, big drops in lava level and recovery. The lava never disappeared at any point in time. It just dropped within that circulating pit. And you can see that since then, we've had fluctuations, but they're actually quite a bit smaller. And the overall trend is an upwards gain of depth, right? With these small variations superimposed on top of that. But clearly the pattern is is climbing more so than we've seen in some other weeks, right? So really, over the last month, we've come down to, if you count from down here, we've actually come up something like 6 meters or so, which is a considerable amount. And we might have 3 or 4 in some other months. Right? So here is the tilt. You can see the tilt has got a slight upwards incline as well, not nearly as much as the lava depth, but more interesting is this pattern that we identified a couple weeks ago that had changed from the big deflation inflation events to little ones that are shorter and not quite as deep, right, as far as the amplitude of the deflation. That's been pretty unchanging pattern, right? Pretty regular there, and maybe a slightly bigger one occurring recently, and something a little weirder happening over here at the right end of this, but still all holds up. And so no huge surprises there. The interesting thing is this Summit SO2 plot, right? So SO2 is still within this range that we've seen as typical over much of the last year. Highest value is around 2,400, 2,500 tons per day up here. And the low value has been down in a 1,000 to 1,200 range. The last one in that range was back on the 21st of July. And in a most recent measurement, looks like it might have been the 12th or 13th of August, came in equally low. That's our 1156 that came from our VOG report there, right? So in one day, or in one interval here, it seems like quite a big drop. And what's interesting is that if you look up at the tilt or you look at the lava level, you don't really see anything corresponding to that. So that kind of makes you wonder what's going on there, whether it's a challenge with a measurement, whether it's actually like possibly putting out less gas, and maybe doing something weird that way. But we haven't had any data since then. So if it was something with the instrument, they are correcting it, and if it wasn't, then they're probably busy trying to redeploy to Samoa and haven't had a chance to go out and measure more. Maybe it's just a lack of data, and maybe if we had more data recently, we'd actually see it back up here again, and it could be as simple as that. So hard to really tell. We're just kind of speculating and just pointing out that there's a little curiosity here, but nothing to be alarmed about. If anything, it's going down, and it's not like it's spiking up to cause any alarm. It's more like, oh, that's weird. So nothing to be concerned with there. Something you want to add, Dane?
I was just going to ask if that was no shot that could be the wind, just making the reading poor, so they just couldn't get a good reading that day. That is a huge drop off, right? We got that cluster of readings, and we got this single data point that's way outside. So it makes you wonder, we don't see that change at the surface. It's very stable, so it makes you wonder, is it wind? Is it a new point that the gas is actually coming out of, and now it's mostly just steam coming out of that spot? That I don't know.
Those are possibilities. And we really would have to have access to the USGS to ask them those questions, right? Because it all depends on how they're measuring it, right? If they're measuring at one fixed spot at the same time every time, then the wind can definitely be affecting it. If they're trying to integrate all the emissions across the whole caldera, I'm not sure how they would do that, but if they're doing that, then maybe be less susceptible to that kind of error. So really would have to find out how they're doing it exactly to really know. But yeah, some interesting. And it really is, like I said before, it's nothing to be really alarmed about. It's a curiosity, and yeah. If it had doubled in rate, we might be a lot more alarmed. Whoa, what's going on there? And let's really be pushing about this. But really, it's like we saw last month. Sometimes you get a low measurement during a deflation event, and if they happen to measure it during those, call it 30 minutes, that it was the lowest of the entire time compared to an hour before or after when it might have been different. Maybe that matters too. Yeah. So we'll just have to wait and see, as usual there. But that is the kind of interesting thing. And you can see it does not correspond to any change on the tilt or the lava depth. That's obvious, which often they do. And that's why we're maybe a little suspicious. And of course, everything that's put online here is instantaneously and preliminary, right? So that's why it takes a little caveat sometimes. And you have to put some human filters on what's going on sometimes too. So that is the monitoring data. Oh, one more thing here. The summary of the lava depth for the whole eruption. So you can see the pattern here. If I can zoom it in, it's way on its right end. jumped on me. Back, there it is. All right, so you can see here we are in this climbing upward trend, and that's a similar pattern to before. We're just having less of this up and down variation. Kind of zoomed way in. The overall pattern of climbing continues there. So our 1-year GPS now here is interesting too. So we look at the GPS for the last year. Let's zoom in on this very far right side, and it looks like you're starting to see a cluster of contraction right here in the last few data points, right? And we've seen variations before, and you've seen little contractional events that occur in the midst of this upward trend. So still need more time to see what's going on, but that would lend you to believe that there could be something funny going on too, right? That you see a little bit of contraction going on. This is between the north part of the caldera and the south part of the caldera. And that doesn't necessarily mean that, there's all kinds of ways that could happen, right? You could, especially that south part of the caldera, it has the summit reservoir to the north, but then it has the Kauai fault zone to the south and the southwest rift zone south, kind of. So there's all kinds of complexity there that could cause it to like wiggle a little bit, which is why you have to really see a longer term trend in these little things to really believe it's something coming from the main caldera. And that's kind of where we come with that. So interesting curiosity there also, but still not alarming and to be determined. And if we saw this coinciding with, for example, the rift zone suddenly expanding, it would be one thing. But here's our rift zone plot, and it's going steadily down with no change whatsoever. So that does not appear to be a concern, which is what we are thankful for. We know that someday magma is going to go back in that upper east rift connector, middle east rift zone, right? And it's likely to happen. Guaranteed, in fact, right? But there is no sign of that yet. And even when that does happen, just to remind you guys, that's that's normal. And then progressing beyond that to where people live, that's a much rarer thing. And so we obviously are conveying all the information to you guys from the USGS, but there's really we're like 2 or 3 steps away from having to worry about anything at this point in time. So that is our monitoring our GPS. Let me switch here. We're going to switch to our earthquakes monitoring, and let's get this switched over here. Oh, I thought I was going to earthquakes, but I guess, actually, first I'm going to put this back. I'm not doing earthquakes yet. I got a little mixed up here. So, more monitoring. Just to mention the USGS report here is what we're summarizing, and you can see no significant changes at the summit or either rift zone. Everything's continuing as normal. And they're citing overflight measurements from August 16th, showing a crater rise of 137 meters, 449 feet, and 104 million cubic meters, 27.5 billion gallons of lava. Right, so that's interesting, that new data point. I haven't quite calculated this most recent increment of it, but we do have, and Dane showed us last week, but just to recap, the most recent thermal maps from August 4th there, showing that active area similar to our satellite view we just saw before, but we saw that the ooze-up spots were more evident as bright spots around the perimeter here. And zoomed in on it, so you can see a little more really how that lava lake is just a small area of that overall large crater floor, the whole thing of which has lava underneath it. Right? So that's the map that was released last week from August 8th, and you can see that last week the value was 102.5 million cubic meters, 27.1 billion gallons. And so we've climbed up since then, and I'll have to update these plots for you guys next week, but here it is, how it currently looks as of before this most recent flight this week. Still climbing upwards steady, a little bit of variability in eruption rate, but still within our normal average, and that really doesn't change our projections whatsoever. So we're still basically on pace. We assumed an average rate of 3.1. It seems like we're still bouncing right around that. A little higher, a little lower, but on average it's close to that still. So it still looks like the next milestone was going to be it coming onto that next down drop block, and it still looks like sometime by Thanksgiving-ish or so. So it keeps approaching, and so here we are, right there on that plot right here, on this path. Right here is a eruption of 2020 to 2021. Then it stopped, and here's a little lull, and it began again, and here we are going And here is where we're projected to go, and here's where we are. So there's a lot more to go than where we've come so far. That's still the point, and no risk of it spilling over or doing anything except getting prettier, really. That's the cool thing about this. So, okay, now we will switch to the earthquakes. And earthquake counts on Kilauea have been normal. Here is the last year of earthquakes. Here we are at the right end, nothing abnormal there. The last month, you can see a little bit more variability, but still bouncing around of our typical average of 30 right there in the middle, nothing unusual. This is actually including, I mean, the reason we're staying at that average rate is because we're including these Pahoa earthquakes still occurring deep in this area southwest of Kilauea. Whereas Kilauea itself, the rest of it is actually fairly quiet, and that's typical of these eruptive times when you have the open valve and the magma is just coming out and erupting lava. And there's not a whole lot of need for build up and cracking of the ground and that kind of thing. You typically do still see the south flank moving, and that's what you still see going on as typical over here. So there's really not a whole lot to talk about on Kilauea for earthquakes otherwise. We'll switch to our island map. You see Pahoa is still going strong. There it is, a couple events that occurred just in the last couple hours. There's a 1.8 and a 2.2 down at 30 kilometers down, so still typical depths. You see there are some around Loihi at low levels, 3 over here. And these ones, let's see, I have to zoom in more to show on a map. There are depths of 5 to 10 kilometers and magnitude 2.5 to 1.6. So still adjustments happening over there, but nothing at any alarming rate. And we can switch over here to Mauna Loa, and you can see that there are still earthquakes happening on Mauna Loa. The largest being a 2.4 right there. Pretty shallow, right around sea level, but not nearly at the levels that we saw a couple weeks ago. And to illustrate that point, let's switch to Mauna Loa here and put up the earthquake counts from Mauna Loa. I'll first give you guys a view of Mauna Loa summit today. All is still quiet up there. Beautiful clear skies. Here's earthquake rates for the past month on Mauna Loa. So there's our spike that we got a couple weeks ago, up to almost 100 earthquakes in a single day. And you can see we've dropped down to low levels less than 20 every single day since the day after that. And so it's back to normal per se. Here's the last year for perspective. So there is that spike was the highest within the last year. We've had other little events that might have given us some excitement as well, but also didn't produce any evident change at the surface, besides what the instruments can record. So we'll zoom out one more time. Here's the last 5 years of Mauna Loa. Okay, so in that context, here is what we have going on at the right end right over here. And it's not nearly as big as what we saw back in spring of 2021, as far as the numbers, total numbers of earthquakes per month. And you can see that we're actually just reaching a threshold of what used to be pretty common back before those events, right? So this was when we were talking about it. Maybe it was in second or third gear, was waiting for it to upshift, and maybe we thought it was gonna do that, but then it basically went back down again. And so maybe now we're coming back up to this level, possibly. That's the first indication of it looking like it's doing that. Right? This pattern of since the eruption began back in September of 2021 in Kilauea. You can see that there's that quiet time, and then here, coinciding with that, we've had a little bit more activity. But really, overall, pretty low still. Not as low as before, right? Before, this is 2018 here, which is why Mauna Loa still remains at advisory and yellow status officially here. So one thing to follow up on, a couple weeks ago, we talked about that swarm in more detail. We did a cross-section from the USGS map that I showed here, right? And we talked about how this had the character of having a range of what you might see as far as like magma migration, but we didn't really have the resolution, especially on this axis. It's all squished together, so hard to see what was going on there. But it kind of, from this very, very limited view, it could have fit. And just an example of how that was not the case, shown by the USGS. So mahalo for the USGS for stepping in with the Volcano Watch last week and And detailing this, I just want to spend a little more time just to correct what I said before. Here is that plot, a little more spread out, so similar kind of range of depths on this axis, but the time, now we're only looking at like 3 days here, as opposed to trying to look at the whole month. So instead of having everything squeezed into one little spot, you can actually see in much more detail that it really is, on average, right around that similar depth of 1 kilometer above sea level. And it has that variation, it's true, but it's not like it's varying from lower to higher in any evident way, right? And this is why the USGS stopped and were monitoring things in real time in the beginning of August when this was going on. So mahalo for that little explanation, and just to emphasize here the one sentence. Where did it go? Nope, it's a little higher actually. So the earthquakes occurred around 2 miles below the surface of Mauna Loa summit, and their locations did not shift horizontally or vertically to another region or depth over time. So that observation that they were not getting shallower was a comforting indicator that the swarm was unlikely to be from magma rapidly ascending into an eruption. So into an eruption, right? So it wasn't coming up towards the surface, but it was at that depth that we've talked about before, is of that typical of the magma chamber around magma reservoir system of Mauna Loa. So it could have just been moving within that system and migrating the pressure from deeper to a little bit shallower within that system that already exists, rather than having to break anything towards the surface. It was kind of pressurizing the balloon that's already there. That's how I would interpret what they've put out here. So just a little clarification on that, and once again, mahalo to the USGS. This is all once again from the USGS. Here is USGS Mauna Loa update for today, for yesterday, I should say. Not erupting. No significant changes, slightly elevated seismicity, 96 earthquakes beneath the summit upper elevation flanks over the past week, mostly shallow, and they're noting low rates of deformation in the volcano's summit region continuing through the past week as well. And no other signals, gas, or anything like that. However, similar to Kilauea, there's a little weirdness going on here. So here is our GPS on Mauna Loa. This is the vertical motion we're looking at. Let's see if I can scroll it up here. Here is the cross caldera distance, north to south. And this is for the last year on top. And you can see that it's been extending and getting farther apart, spreading as magma's coming in. It's still swelling. Sometimes a little faster, sometimes a little slower. Sometimes a little faster, but zooming in here on the right end, it looks like within the variability that we've seen, and so not convincing yet, but it looks like it may be climbing a little faster than we've seen in recent times. Not at an alarming rate, but in an interesting way, right? This one data point is kind of off on its own. You probably want to ignore that one, but still you see an upward trend right here coming up. Right, and I brought this page up because it's starting to show, if you look at the last 5-year plot, it's starting to show a little bit there on there as well, right here, coming up a little bit here. But I also want to put the context of what is going on, because a little rise is just at this point, a curiosity. Here is that previous event back in March 2021, where it had a steep rise and came back down and settled, and of course no eruption. It was just adjustment within the volcanic system itself. And note that it actually can go the other way, either way, adjust in that manner. So that's the distance across the caldera, and we're also going to look at the vertical motion just up and down at the one station at the summit there. And this is another way to get a handle on this. And so you can see it's been rising, which means it's getting pushed from below, right? It's been swelling, rising, 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 rising. But then here at the very right end, it appears also to be going steeper. And now it's harder to discount these high data points because there's several of them all clustering upwards over here. So we may be seeing some adjustments still happening in Mauna Loa, right? And there is that 1 year, and here's a 5-year. And once again, we're starting to see what looks like a little swing up. But in context, this has happened before in that signal too. So it is still adjusting. You can imagine magma still moving around in there. It's swelling and building, and of course this fits right in line with what we saw USGS release a couple weeks ago as well, when they said that there were, what does it say here? There's evidence for a few millimeters of inflation on Mauna Loa. Right, so a few millimeters of inflation, it might be what's starting to manifest on these plots, right? So, however, if we're looking at the scale here, this is now in meters. Right? So this is 1 centimeter. Right? So we're looking at changes from maybe an order of centimeters coming up rather than a millimeters, expressing more recently than that shot was taken. So that's still an open book, still changing, nothing alarming yet, but as always, we're keeping an eye on it and summarizing USGS reports on it for you guys. So that is Mauna Loa. We'll take a quick break here, Dane, and we can say any thank yous, do some questions on this. We are still going to talk Pohoiki right after we take our break, and then we'll do Samoa at the end here. So, all that said, what have you got? Oh, I can't hear you.
There we go. First, want to thank everybody for tuning in today. We rely on viewers like you to help get this type of messaging out to everybody. We don't have an advertising or anything like that. So word of mouth and the shares that you guys give us, the likes and comments, those all help with the algorithm and gets us out there. We did have one supporter come through that I want to acknowledge. Continued supporter, Chris Kiki, with a $50 donation, says, always appreciate you guys, your knowledge and the updates. Thank you. And we appreciate that support. It really does help. We also want to thank our longtime supporter, Kilauea's Bar and Grill. They have 2 locations, one in Pahoa, one in Orchid Land. They have 2 unique menus, 2 different hours. So definitely check them out. And, times are rough, and we've gotten news recently that they're going to have to back out of being our longtime supporter, which we understand. The economy isn't easy right now. So we appreciate them. We appreciate their support, and, we'll be okay without them, but we still really value their support. We're really getting going and hadn't figured everything out yet. So Thank those guys. And yeah, anything you want to say there, Phil?
Yeah, no, for sure. It's just what you just said. It was a huge boost. We've been trying to get off the ground for a while. We've kind of been upping our production little by little. We're getting more and more support. And early on, it was especially hard, right? So that really helped us bridge the gap. And, of course, we still need all the support we can get, but we appreciate that they've helped us out for so long already. So mahalo, you guys.
Yeah,
mahalo,
definitely.
Leslie.
All right. And with that, I don't even know if we have any questions that came through yet.
Well, that's a first.
Yeah, I know, right? If anybody does have any questions, we will be looking for them. I do have a question, though. Just let's talk about that Mauna Loa signal for a minute, because that wasn't there really last week. I mean, there might have been one data point, but usually we kind of, with the GPS, ignore those one data points because they're kind of weird to work with.
Mm-hmm.
But yeah, it does definitely look like now that we have a week more worth of information, that it does look like it might be trending upwards. We've seen that before, those short trends up. And how long are we after that earthquakes flurry? About 2.5 weeks now, something like that.
Yeah, I mean, it seemed like it was August 1st or 2nd, maybe. Right, so it's 19, so 17 days ish. Yeah.
So at the time we were kind of saying, wait and see. Mauna Loa is really good at pump faking and making us think that it's going to do something, and then it settles back down. So here we are. If the signal continues at that angle without any change in earthquake activity, would that be significant in your mind? Like, say, in a week from now?
If so, I would say that we may be in second gear at this point in time. Maybe that puts us into third gear if we can see it sustained. But there's still several other gears to go before we'd be really worried about it, because especially in the context of showing what happened within the last 5 years, right? And we've had these shifting into second gear, even third or fourth gear before, and then not actually gotten all the way many times. So we still have many other stages to get there before even, but yeah, it's like the first thing it's done in a while. That's why it's noteworthy, because if you look at this 5-year graph, the last time I did it was back in spring 2021. That's over a year ago. So that's more than usual part. It's like, oh, it didn't do that for a whole year. So.
Right. And one thing I wanted to highlight that you were talking about, but it's going to be a little bit more important later, is you were mentioning the baseline green, the normal, what is considered normal on Mauna Loa, and that was kind of first established during the 2018 eruption. Now, when we go to Samoa, we're going to be seeing something somewhat similar here, right? Where we didn't have a baseline established. You had to get this elevated activity, and it's kind of like an inverse, right? Before we had the background established, but we didn't have what yellow would be at the Samoa locations. Here we had yellow established, but not really what green would look like. And then we got the readings, and now the Samoa is getting the readings. So it's like, all right, this is what elevated activity in Samoa at these Samoan locations looks like. So when we start going over those notification, that's kind of important to just look at, to realize that these are still new, right? A lot of these classifications are relatively recent or still happening.
Yeah, absolutely. Yeah, so yeah, it's interesting, Samoa, especially when we get to that. And we will shortly, but I did wanted to give you a chance to talk about Pohoiki first. And I don't know if you want to take the lead and say whatever you want. We don't have to go super in depth if you want, but it's...
Yeah, I'll just try and give a little bit of a context, but before I do see another super chat come through from our longtime supporter Gary Bryan for $35. Says, thanks, Philip and Dane. Appreciate that longtime support there.
Mahalo, Gary.
All right. Pohoiki. So yes, let's do a little context for anybody that might not be aware. Pohoiki boat ramp is one of the only boat ramps in the area, probably along the coastline, especially. You're talking 50 to 100 miles in each direction. Not as the bird flies, but going the long way around. These grounds are traditional fishing grounds. These have been brought up generationally through the Hawaiian culture and stuff like that. But not only that, this ramp brought in a significant amount of revenue. They would bring in somewhere into the neighborhood of making it the third highest grossing boat ramp in all of Hawaii. So in 2018, the eruption happened just to the north of it. We have a 3.5 mile wide lava delta that forms, and it ends up taking part of Pohoiki, but not the boat ramp, and not the what would be considered first bay, second bay, and further down to the south. So it parks itself, and then after the eruption ends, sand starts to inundate the area. Sand and loose sediment and all these little bits of rock and pebble. They end up blocking the boat ramp and forming a beach that is significantly, probably a football field wide, just to, rough conceptualization. So since 2018, or let's going ahead a year from 2018 to 2019, we saw sand continue to inundate that area. Then after that, it kind of hit into an equilibrium of sorts, where sand stopped getting wider and started moving further down the beach. Then we've been working on trying to get the boat ramp dredged, right? Reopen the boat ramp in any way, shape, or form. So that brings us up into the efforts that's been ongoing for the past couple years. And those efforts have ended with Pohoiki is the only option for a boat ramp. Everywhere else is unsuitable for one reason or another. And once you get out on the boat and start going around this area, you can really feel why Pohoiki is the landmark that it is for the fishing community. So yesterday, there was a pre-design report that was that was presented by consultants working with the state to come up with the pre-engineering of what the dredge would look like. So this is going to be kind of a live this is going to be our initial reaction from that meeting that just took place, and what we were able to learn from that, and what that kind of means, and what our initial feelings are, just to give a little bit of context for what happened yesterday.
So
go ahead.
I was going to say, we obviously streamed it yesterday, so if you guys haven't had a chance to see it, you can check it out. We have some audio issues, but you can hopefully navigate those if you're curious enough. Sorry, Dan, go ahead.
Yeah, and so yesterday we had this meeting, right? Community meeting, and it was a packed house. There were probably 150, 200 people in attendance, overflowing all of the doors. Just huge support for Pohoiki. But the report that we were presented with, in short, was disappointing. We expected a couple options that were not going to be seen as good by the community, and instead all the options are kind of kind of crazy in our mind. First option was just do a baseline, just scrape out the channel as easy, cost effectively as possible. No concerns about it refilling. Second option is very similar, except it's going to be slightly wider. And then the third option was a total engineering project with jetties and making it into a permanent solution. So those were the three options that were handed out. The disappointing thing is that the community has been asked to make a decision at this point, or start to make a decision. And we've been presented with all this stuff, and the news media has been reporting on it, but the report is still not publicly available. It still can't be reviewed. We still can't tell you what's in it. We still can't even, establish how solid it is. So we can't even say that much about, which option is the best option, other than the options that the engineer himself said wouldn't work, which is basically option 1 and 2. I don't know how to break it down better than that, because it's frustrating, right? We've been working for years to try and get the fourth option, which is an idea of basically taking all of the sand out. On the slide that Philip has up, it would be all the sand from the right of the screen, just about to where the second red jetty, that's what that red thing is, would be, if you remove all of that sand. Now, this was analyzed by the engineers, recommended by the engineer that was in attendance yesterday as one of the best solutions, and was not presented to the public as an option at all. So yeah, it's frustrating at this point. We're still waiting for the report, and really we can't say that much more until we have the report that's supposed to be able to have the data to prove what was asserted in this presentation, but the presentation didn't have any data. Or if it did, it was single data points.
Yeah, I think the work that was done, I think is in line with what's typically done. But the problem is Pohoiki is not a typical problem. So the engineering, the modeling that was done is all ocean waves, which you need to do that. Of course, you have to do it every time. Every time they do this kind of work, they do that. That's standard. But that's not enough, right? That's not enough modeling, right? And my objection was that there is no treatment whatsoever of the rate of sediment accumulation or withdrawal, right? So it's obviously a very hard thing to figure out. If it was super easy, we would have just done it for you guys already, right? It's a huge, complicated project. We could do it, but these guys have a contract to do it, and they're getting paid to do it, and we don't get paid at all for any of this stuff. So why should we do it, right? The waves only indicate that erosion happens, right? And that sand is going to go towards that area. That was known already. That's known of every sedimentary system in the world, right? Harbors, that's typically that have to be maintained and dredged out of some amount of sediment. So trying to reach zero sediment is not the goal here. The fact that some sediment comes in at all, is just kind of irrelevant, right? It's like trying to, not to bring the whole politics into it here, right? But the whole COVID thing, right? Trying to get to zero COVID is pretty impossible, right? Trying to get to zero sand deposition is pretty impossible. There's got to be some level that you can put up with and maintain that your infrastructure can handle, right? And so my question, of course, is, I think it's totally possible that infrastructure maybe is absolutely well justified, but it's not convincing that it is, because we don't have that information of whether, we know which way the waves come from, we know which way the sediment's going to come from, and so if a structure is needed, we know where they should go. More than likely, that's what they identified in that option there. But it's not convincing how much is still accumulating, right? And it's hard to tell. And there are real reasons to not really know for sure, right? One is that they didn't collect a whole lot of data over the last 4 years, right? There's a couple of data points. Maybe you could augment that with satellite information, right? Maybe you can augment that with some other remote sensing data, right? one of the other issues. What was that? I lost my train of thought now. Okay, so relation rates.
Sorry,
go for it.
Oh no, I'm just looking at this and hoping would interrupt me if you regain your train of thought there. But also they were talking just about the sand accumulation is they used 2 aerial overheads to say that the sand was still continuing to accumulate. But the problem with that is if you were familiar with down there, there's oscillations day to day, right? Taking a single photo from above and being like, oh, look how much the sand moved. It's like you might just be catching that ebb and flow and not seeing that big trend, the overarching trend by doing that kind of simple polling.
Right. So yeah, thanks, Dean. Yeah. So I mean, we'll start with that, right? Because okay, here's a map that they showed, and on this map there are 2 pairs of lines. A pair of lines that's in green, you can't see the label because it's cut off by a person that's set over here. But a pair of lines that's in green is 2019, and a pair of lines that's dashed is 2022. And these are what are being called the equilibrium crest lines, right? So it's like the high berm on the front of the beach. And the reason I focus on this is because, exactly as you say, everything that's seaward of that is always moving all the time. And it varies with all the variations of daily, weekly, monthly, whatever the ocean's doing. That's the area that's going to vary. So if you, for example, pick out the berm, you're somewhat averaging out or taking a maximum or taking like an integrated what happened over the whole time to, so it's a little bit more stable thing to measure than, let's say, the actual shoreline or anything happening seaward of that, right? That's why I liked this slide in particular that actually shows that.
Yeah.
And if you compare the line from 2019 to 2022, they're not that far apart, right? So it's true that there are concerns because as the ground slopes away over here, there are drop-offs that occur, right? And so the one valid uncertainty is, how much can this shelf how much sand can the shelf actually hold in the first place? If we're at the limit because of the slope, then maybe you can't grow it because of the slope. But if you were to take some away, it might actually go back in and do the same thing again. That is possible. It would depend on the rate as well, right? So that's definitely a possibility there.
Even
the other thing is that is that you could be having all this erosion occurring, and it could just be washing by here, right, without actually piling up. But you just can't know that unless you start collecting some data about it, right? And so what I was gonna so I mean, is that triggering anything, Dane?
I mean, to me, I'm just not overly excited about the berm either, because basically what the berm would tell me is the biggest thing it'd be telling me is, was there a south swell recently or not? Because the slope of that thing and how it where it starts when a south swell comes just drags everything back out and makes it pushes the top back and makes it a much more gradual slope. And then when you get the normal swells, it builds up, puts that ridge closer to the water line. Then the south swell comes and just drags it all back out, type of thing.
Right. It's not perfect by any means, right? But it's like, it's way better at measuring a shoreline or measuring anything that's towards the ocean from there.
If you did it at the same time of year, you'd have a more likelihood of that ridge being consistent between, like if you're doing it in the summer, right, each year.
Yeah. So there
of those winter swells coming through. There's
variations day to day, week to week, winter to summer. Yeah. And so, but the thing is, that's the best average you can get, that nature, or a maximum point of nature, right? So it's like something comparable. Of course, you have to compare how big were the swells in those intervening periods, right? Like what actually made that berm? Were there bigger, but if you can get past all that, because we really are data poor, we really have the whole issue is there's no data. So let's squeeze out every drop of data we can from what they did present, right? It's kind of where I am. And this is the best, really the only thing that I can get out of that, right? Is gives you some estimate of that, right? So I think really you could use the bathymetry. There was LiDAR bathymetry done in 2013, so the bathymetry is known really well. The state pre-eruption, the state in 2019, the state now. And so you can actually do a couple of intervals and rather than guessing blindly, you could make an educated guess that you know is going to have a lot of uncertainty, but then you can then test that, okay, like and go from there. And because to me, that's the biggest piece of information that's missing, is how much sand is being produced and how much is accumulating. How can you possibly know what to expect or what to design or to choose if you don't know that fundamental piece of information? Right? So if you're assuming worst case like they are, then you can say, yeah, okay, worst case is we have to build these 2 giant jetties and I got to take everything out, and there you go. Right? But I think they could do a little better. Right? You know, that's what I'm saying.
Yeah.
So
we'll be going over, or the plan is to, once the report gets released, we'll be able to go through it and, provide much better detail about all these different options and what they're suggesting exactly is going to happen. But as right now, we're still just working off of the presentation. Right?
Yeah. I will say, though, that these guys have been super responsive. We've been engaging them about all this information, and they've been really responsive. They really, they stopped what they were doing. They could have just chosen an option and gone with it, and they didn't. They actually stopped and had a meeting and came into what they knew was going to be a hot situation, and did it anyways because they wanted to hear what people had to say. So kudos to them for all that, right? And they're trying, but man, I mean, it's frustrating that it seems like a setback in some ways, right? That there is nothing new that we didn't get in a report in 2019, except from possibly updated wave models, which really the waves haven't changed that much. So really, it's the same stuff, And
that report, for those that didn't know, was introduced and widely rejected by the community.
So there was a lot of meeting after the public meeting was over yesterday. There was a lot of small group discussion that occurred, and I came out more optimistic after that, because it did seem like they had heard a community. The community, in the end, said that they would like a multi-phase solution, right? Something with a dredging to start, and eventually working towards, if necessary, that full-on dual pier harbor, right? But something that long-term is going to work, and short-term will get them in the water as soon as possible. Those are the requirements.
And doesn't close in 2 weeks.
Yeah, that's what I mean. That's what I mean. But it's going to work. Yeah. It's going to actually be functional for some, functional, right? Yeah. So like they can cut a channel that's going to be functional until they can keep the next phase, get to the next phase, right?
Yep.
And really, if there are setbacks, then you're gonna have data. You're gonna know something happened and something didn't work as you expected, and then you can adjust from there, right? And that's really what we're all about here, is having data, obviously, and looking at the data and looking at the trends and all that. So we may come back and do some data analysis on this too, depending on what is released in the report. But that's all I have to say for that today. I know we're going to have more on this in the next week. We're going to have guests and all that as well. So we will. If you have anything else, Dane?
No. We will hopefully meet up with Kaiko Marzo next week and do something with him as well. I know a lot of people know him, but he's big figure in that the boat ramp area, and love to hear his thoughts on it, and especially once we get more information on it.
He's had to stop fishing, right?
Yeah, I mean,
that's
going out of Hilo.
Fundamentally, it takes a bigger boat, more maintenance, more gas, like all kinds of issues. Yeah, less time with your family.
Yeah,
really rough.
It's rough. Yeah. We do have 2 super chats that came through. I want to recognize Skajit Ed says, appreciate you guys. Realize you're not high tech, but great for the greenhorn. Thanks for your efforts. Appreciate it. Yep. We're not a professional production. This is webcams and things along those lines still.
We'd like to be. We're trying.
Yeah. It'll take a lot more equipment than that.
We need to buy some more gear, right? For us to, the remote thing is a little hard for us right now. We're working on that, and
2 pineapples came through, and appreciate 2 pineapples always. Aloha, Phil and Dane. Appreciate all your hard work and weekly information. appreciate the support there, Two Pineapples. And if you haven't checked them out, they do live streams from up on the volcano. You can chat with them and get them to, look at what you're trying to get to look at. They have all kinds of cameras and stuff like that. They have a real production set up for remote streaming. So we really appreciate them. All right. So I don't think I didn't see many questions come through during that. What was the final recommendation? Saw Phil's input. There really wasn't a final recommendation. It's more preliminary. This is like your pre-report briefing of what the report's going to contain. Is what we got. So we don't know yet what the decision's going to be. It's really hard when the range on what option 3 would entail, that full jetty, range from something like 30 million to like 100 million or something crazy.
I think it was like
it's like
30 to 60-ish, 62.
30 to 60-ish.
Mm-hmm.
All right, something like that. But that's a huge range to be working with. That means it's not well defined, that part of the project or that aspect of it. So yeah, maybe there's a few different versions of what version 3, like a 3A, B, and C, that are included in the report. We really don't know yet.
Yeah, I would summarize it that they've said that no single option seems like the right way to go, but rather that multi-stage solution, right? So something like starting with that option 2, that's what they call the test dredge on steroid, where it's a slightly bigger area that maybe doesn't close up as quickly, that might give you time to continue working on this alternate plan to get the jetties and things in if needed, or scoop more sand out first and then put in the jetties, or however it actually turns out. That's the best that we know at this point in time, right? So we will keep reporting on it for sure.
There is a good comment here. Volcano Nerd says, way more high tech than Phil doing everything on his iPhone and a tablet during the eruption. I remember sending you a pointer.
Thank you for the pointer. Yes.
Wild times.
Yeah, I was like, where is the glare? And am I too close to the generator? But I have to be because I need to plug it in because I've been here all day and my thing is dead. Or yeah, we call it the guerrilla style. Yeah, do what you got to do.
Right.
Kind of like
just
yesterday.
Yeah.
Did we yeah. But in the future, we would like to actually, have enough to actually pay someone to help us with that, right? And you guys know who's good at that already. Won't say anything more than that right now. So, all right, that's our community corner. What we'll do is switch to the Volcano Watch next. So let me get this on the screen here, our Volcano Watch this week. And there it is. HVO responds to American Samoa earthquake reports on Taʻu Island. So so first of all, my big disclaimer, I don't know how to pronounce Samoan. I am going to pronounce it as if it's Hawaiian, which I may be not the best at either, but that's the best I can do. So apologies to anyone who knows the language better, and if you can educate me, please do, but otherwise I'll give it my best shot here. So, Taʻu Island. Earthquakes have been felt since late July in the Manua Islands of American Samoa and South Pacific. These earthquakes are likely associated with magmatic activity beneath the islands. So I'll break here. USGS actually is responsible for all the volcanoes in American territories, states and territories, right? And the USGS-HVO, Hawaiian Volcano Observatory, is this most western branch of the Pacific. And so they're in charge of responding to anything happening, whether it be Samoa, Northern Marianas, those kind of outer islands that are closest to Hawaii, really, than anywhere else in the United States. Right, so that's why HVO is involved. That's why they're putting out alerts, and because I imagine many of you guys are seeing and hearing this, and it's a chance for us to continue our education, especially as it prepares towards these kind of ramp up of possible disasters, right? To keep that in mind and take it as a learning opportunity for us here. So the USGS became involved after being notified by a lot of the weather infrastructure in Samoa, but we'll get to that here shortly. First, there's a map. So let's zoom it in way over here to this corner. So you can see Hawaii, American Samoa, and New Zealand are kind of in line with Samoa over halfway towards New Zealand from Hawaii. Right? So it's there. That's the absolute location there, and a little more detail here. You have. Let's see, what can I show you guys? There's a lot of different things going on here. So here is American Samoa, this little box here at the bottom. And the main island, Tutuila, with the capital Pago Pago, is the biggest landmass over here in the west part of this island group. The Manua Islands is this cluster right in here. That's what we're talking about. And there's also a seamount to the east called Vailulu'u. I'm saying that right, seamount, which is the most active part of Samoa. Okay, and so zooming in on the Manua Islands over here, that's where the USGS is deployed. Here is Taʻu Island, the bigger one, right over here. And there are two islands, Ofu Island and Olosega Island, with a very, very skinny channel between them and a bridge between them that are kind of considered one volcanic complex as well, right? So you have number 1 or number 2 and number 1 right here, right? They've outlined a couple of things that are interesting. There are national parks there. So there's a national park over here on Ofu. There is a national park on Taʻu that is most of this southern part of the island right over here, right? So the USGS came first into Fitiuta here and put in a seismometer. That's what this little pink square is right there. So a new seismometer number 1 went right there. And new seismometer number 2 is now over here on Olosega Island, over there on that site, right? And they wanted to likely space them apart. It sounded like from the reports that they actually came in and deployed for a few hours that other earthquake somewhere else on Taʻu, but then moved it over here, and obviously it gives you a little bit better resolution. Now the issue is when you only have 2 seismometers, right? Let's say that you can say, oh, we can see a wave coming from, let's say we know it's from 10 miles away from here and 10 miles away, or 12 miles away from here. So around this plot, let's see, I need to switch my, there we go. So you might have around this seismometer, you might know, okay, well, the earthquake had to occur at a radius of somewhere around that far. Call it something like that, right? So there you go. Then you might have this station and say, okay, well, we know it's from that one, it's going to be a much different location. It's going to be something like this. So, and you draw like a circle around it as well. So when you only have 2 circles, then you have a non-unique solution because you have 2 locations where you have candidate seismicity, right? So the way I drew those circles really big, maybe it doesn't do it as justice, right? But if I draw, let's say we have an arc that goes something like this. And we have an arc that goes something like this. And you can see that maybe you don't know exactly, right? So anyways, that's the issue with having 2 seismometers, and so that's why you can imagine they're going to deploy more seismometers and more teams coming up in the next week here to really tell what's going on. However, before I move on from this map, the reason I drew that like the way I did is if I zoom it into way over here, you can see that they've outlined an approximate location of the 1866 eruption, which was submarine under the ocean. And that's one of the more recent eruptions in this area. So considering that, right, and they are saying, and I'll read this below here shortly, but that the earthquake's going to be closer to Taʻu than other places, that really maybe it's in between these zones, but maybe you're looking at something over here, or it's hard to know exactly. It could be really anywhere, right, in this region right in here. And so let's see what they're giving for information besides this. Earthquakes have been felt since late July. Let's see here. Volcanoes in Samoa are similar to those in Hawaii. There is a hotspot there called the Samoa hotspot. The Pacific Plate moves northwest over the hotspot, just like in Hawaii, and leaves a hotspot trail of volcanoes. That's pretty similar. The volcanoes rise out of the ocean from 15,000 feet from the surrounding seafloor, so they're big land masses that come up from the seafloor, and the tops poke out. So similar in that manner as well. and currently centered on Wailu'u Seamount. Right, so all the islands of the Manua Islands, Ofu-Olosega, and Taʻu, along with the main island of Tutuila, are all considered potentially active as they have erupted within the last 10,000 years. Tutuila is the most populous island in American Samoa and is where the capital city of Pago Pago is located. The youngest eruption on Samoa on land is on Tutuila and occurred approximately 1400 to 1700 years ago. Right, so if we're looking at its 2020, you're looking at something like 500 to 800 AD-ish, right? That period of time when that eruption occurred on land. However, numerous submarine eruptions have occurred more recently at volcanoes east of Tutuila. So we talked about the islands already. Taʻu is the largest of the Manua group, and it's got rift zones to the northeast and the northwest. In 1866, submarine eruption formed a cone in between Taʻu and Olosega, so that underwater location has a cone. The youngest seamount, Wailu'u, is 25 miles east of Taʻu, submarine, and it reaches 2,000 feet beneath sea level, 600 meters beneath sea level. It's erupted multiple times over the last 50 years and has grown a cone within its summit caldera. So we'll look at more maps here shortly, but let's finish this report. Based on reports and activity, Taʻu and Wailu'u were identified as likely possible sources for recent earthquakes. It was initially difficult to confirm a source because until a few days ago, there were no seismometers close enough to determine a distance to the source of the earthquakes. The latest data, obtained from rapidly deployed microseismometers, indicate the source is closer to Taʻu than Olosega, and not close to Wailu'u. The earthquake swarm is most likely due to magma movement beneath the volcanoes and not tectonic faulting. So it is likely magma, right? They're reporting about 20 earthquakes a day still in the area. We'll come to that in other reports. HVO became aware of these reports on August 7th. Federal partners, National Weather Service office in Pago Pago, Pacific Tsunami Warning Center, National Park Samoa, Marine Sanctuary Samoa, and NEIC Earthquake Center Information Center are all working together with officials to respond to the situation. HVO staff traveled to Samoa on August 11th to consult with all the partners. More equipment and scientists will arrive in Samoa later this week. They're getting help from the USGS Alaskan Volcano Observatory, HVO, and the Wellington Volcano Ash Advisory Center, because they are specialists and in remote monitoring, so satellite stuff, right? Satellite data. So they're using satellite data to look for thermal anomalies, volcanic plumes, or volcanic gases related to activity. Obviously, when a satellite catches it, you probably already know what's going on because there's someone tweeting about it or online or something like that, right? But that actually gives you the data you need to then figure out the full scale of the event. So, prognosis. It is unclear if this unrest will escalate to a volcanic eruption. If it does occur, it will most likely include slow-moving lava flows or low-level explosions localized to a small area. Other hazards could include volcanic gases, ground shaking, and local tsunami. An eruption like Hunga Ha'apai in Tonga earlier this year is extremely unlikely, underlined, as it's a different kind of volcano. Volcanoes in Tonga erupt much more explosively than the ones in American Samoa and Hawaii. I acknowledge and thank everyone, especially Manua Island residents, for their observations. Mahalo and fa'afetai. So that is the Volcano Watch today. Kind of synthesis that integrates a lot of what's going on. You can go to the HANS system, this Hazard Notification Service, and look back at all different updates that have been put out. And for most of the week, these have all been HVO information statements, as you can see right there. Right? So here's the one from yesterday. They've been coming up in the afternoon. Taʻu Island Volcano. At the time, it was alert level unassigned, aviation cone unassigned. The summary here. The swarm continues without significant changes. Approximate 20 earthquakes, per hour. Not per day. 20 earthquakes per hour are being located by 2 microseismometers installed in the Manua Islands. Most events are too small to be felt. The largest magnitudes are between 2 and 3. Satellite data from the past 24 hours showed fairly clear views and no signs of activity. And more seismometers are being installed today, and a permanent monitoring station being delivered this week. The first earthquake report felt was on July 26th, so that's almost a month ago now, right? Or 1 week short, 3 weeks ago, really. And they vary in intensity there. So yesterday they put out an heads up, we'll call it here. Volcanoes in the Maunaloa Islands have not been previously monitored and were classified as unassigned in a USGS volcano alert system. Current seismic monitoring shows the level of earthquake activity is above normal, green, right? And that the appropriate level should be advisory, yellow. Therefore, announced yesterday and implemented today, on Friday, August 19th, today, the USGS changed Taʻu and Ofu-Olosega volcanoes to advisory yellow status. This change acknowledges new level of activity, but it's important to note that there's nothing changed from yesterday to today. They just actually are just updating their system, right? So the change occurred 3 weeks ago, and they're still following through with all the deployment and response, right? So as of today, you can actually go and look. The USGS, oh, that's the wrong one. There it is. The USGS has a website just for Taʻu Island that you can get from the main site there. And it's not loading very much, but now you can see it's showing yellow advisory. You can click the notifications, get all that stuff. This page has more information on volcanoes in Samoa, some quick links, more about HVO, right? They're also making sure that people in Samoa who maybe didn't follow HVO ever before, had no reason to, now have some connection to what's going on there. And this seems to be still in development. There is also monitoring data on here, so this is pretty cool. Let's see if this actually works. I'll click on the view data. And this is still in the process of being set up, so I'm not sure it's going to show me any data actually here, but it's trying. Oh, there, yeah, it's coming in finally. So there is our live seismic signal of the earthquakes over in Taʻu. So you guys can find that off of that Taʻu page right there. So not all swarms that result in eruptions. Here's the website in case you're wondering: usgs.gov/volcanoes/TA-U-island. There. It's also possible that the swarm is an early precursor to an eventual eruption. At the time, we cannot determine which is more likely, but a large explosive eruption similar to Tonga is extremely unlikely. Right, so that's analysis. There's a response. We've talked about that already. Coming back in. More staff with more equipment. And that is all I think I need to highlight for you guys here today of this, right? So today, let's see if I come here to this Han system, and I'll show you guys how I do this, because it's a little, I usually start at the top and I'll click last 7 days, and right there at the front, you see Volcano Observatory Notice for Aviation, VONA. There's a new acronym. VONA was issued today, and it's basically saying aviation code yellow. And this is for Volcano Ofu-Olosega. And this is basically putting out that alert to aircraft, right? And so a lot of the text here is very similar to what we saw in other reports here. But you can see here, designation previously was unassigned. This designation does not reflect the change in the behavior of either volcano. It simply acknowledges a number of size and frequency of earthquakes that by people on Taʻu Island and Ofu-Olosega are well above typical background levels, which they would describe as normal green. So that is the key of it there. Everything else I've shared there. But scrolling down. There's also a volcanic activity notice. This is the VAN, right? This is the ones that we look for as a big indication that they're stepping up the alert level. And so because they're coming out of unmonitored, basically, to monitored, they're issuing an initial VAN for Ofu-Olosega. There it is, and similar thing to what we just talked about. But then there's also a second pair of VONA for Taʻu, and scroll down enough, VAN for Taʻu as well. right? So really 2 VANs and 2 VONAs for the 2 volcanoes that basically they're not sure which one it's closer to yet, but it's affecting people on both islands at this point in time. So I think that's most of that report data to share there. Let's see what else we have. The USGS has made sure to rewrite their color key in Samoan as well, so that it can be accessible to the Samoans. So I thought I would show that on the screen here, in case you're curious to see the colors, the names of the colors, and what the Samoan language messages look like. So there they are. And yep, there is our seismic, and let's move on and show you guys. This is see here, Google Earth trying to load. Going a little slow. I like to preload all this stuff on here, but it doesn't always stay in the tabs that you stick them in. So there it goes. Dan, you got something you want to throw in?
I was just going to say, whenever we stream, everything takes forever to load, it feels like.
Yeah. So here's Google Earth. There's Hawaii, right? And down here, when you look at this map of the seafloor, there is this trench that takes this 90-degree turn right there, and right at that corner, that's where Samoa is, right there. So if I can zoom it in, it gives you an idea of there's Samoa. If you're curious where this relates to Tonga, Tonga's been mentioned by the USGS. Here's Tonga. An important key difference here is this on this trench, right? Samoa is on the east side, and Tonga is on the west side. That's fundamentally what makes them different kinds of volcanoes, different volcanic systems. So we can dig into that a little bit, but that's the kind of context of where things are. Let me zoom into Samoa a little more so you can see what that looks like. So Samoa proper and an American Samoa over here. So zooming in on American Samoa, you can see it's smaller than Samoa proper. There is that larger western island, Pago Pago. And if I scroll it to the east here, you can see some of this bathymetry, right? So there's a chain of volcanic centers here stretching off to the southeast. And these two group, that's Taʻu and Ofu-Olosega. Forgot the names already. I'm getting more practice still. So that's what they look like. I'll zoom in as much as possible here into these two islands, right? Because I talked about how these are really, it looks like one island, but if you zoom way in, there you can see the Osaga Strait and the bridge right in between them, across from one island to the other, just like that, across that little channel. And so that's why they really treat them as one complex, Olosega Ofu. You can't quite see from the bathymetry very well what's going on here in between these two islands. There's like an indication of maybe there's a bump right there, right? That could be that submarine cone from that 1860s eruption right there. Can't quite see it. There is Taʻu, and you can see clearly a big collapse right here. This seems like the center of the volcano is actually over here. They said that the rift zone is both, what did they say, northeast, northwest? Coming off from here, in this direction, and I think it's in northwest, or I forget northwest or southwest, but the main caldera being over here, and you can see that's missing the south part of it too. So there's some caldera and some collapse mixed in here, and without really knowing more details, I'll kind of leave it at that, as the complex is involved. But let's zoom it out and let's pan it a little further to the east, and there we come to the center of the current hotspot, that's Seamount, right over there, right? And you can see there is like Summit Caldera and a new cone that grew inside of it right there, in the most recent activity. Okay, so a couple of NOAA images here, so it's kind of comparing Hawaiian hotspot track, Samoan hotspot track right over there, and relative locations. Zooming in on Samoa, there is that Wailu'u center of where they think the head of the hotspot is, and there's some other atolls and things kind of further east that the NOAA plot was describing in this paper, but we're interested more in this hotspot track that comes off in this direction, right? So there's a head and the hotspot track goes off like that. And a trench right over here in the corner. So this is a tectonic map, right? So Samoa is a little bit off the map right over here. Just to show you guys what this little weird bend actually is, you have in blue the Pacific plate, and it's moving kind of in this direction. And where you see this line with these black teeth, that means that the Pacific plate's diving underneath this Australian plate and subducting right over there. That's a trench right there. So you see this really weird geometry. It's diving under in some areas, it's sliding past, and similar to like a San Andreas style strike slip fault situation there. You have some spreading centers where there's actually a new ocean trying to leak out and eruptions happening out of the seafloor over here. It's really a geologic mess in this area right in here, right? It's kind of the setting. So while Samoa is this hotspot volcano, it's got all this other mess happening right next to it, which really complicates what's going on and makes it harder to understand. So once again, there's Samoa, there is the Tonga Trench, and a plate going off in this direction like that, right? Okay, so to advance it, looking at this paper from Nature Scientific Reports by Strack and Schellart in 2018, they're looking at all these different factors of the Samoan hotspot, and I really wanted to just highlight this image in particular because you really can see how the slab of the Pacific plate's coming in and it's diving under right over here, right? But then there's this curvature, and so the plate's actually curved and it's ripped apart, and you have all the spreading center mess over here. And so here is a current predicted hotspot head and hotspot track going off this direction. But what you probably can't see unless I zoom it in more, and maybe I can't do it enough, but there's some of these dates that are in orange, like that one, and like that one, and that one. And so there actually are some young eruptions that occur out of sequence with a hotspot, right? And that's because of this weird mess that's going on over here. And so really, you have your basic hotspot that's going on, and you have all this superimposed weird mess in it. And I'm going to keep it really generic like that today without going into the details of the dynamics of why that could happen, but just know it's really weird, right? Because that's how come you can have these basaltic volcanoes, hotspot volcanoes, really close to what can be these island arc volcanoes. And to help remind you what that actually is, let's talk about that a little bit. Here's a USGS plot of these different tectonic settings. Here's our hotspot like Hawaii coming up through the lithosphere and crust and building a shield volcano through the ocean right there. Right, that's our shield volcano, hotspot volcano. And then when you have a subduction going on of one slab underneath another slab, then what often happens is you bring down this layer of hydrated sediment, and that sediment is bringing water into this deep hot part of the volcano. The water then essentially migrates out of the sediment and comes into this overlying slab. That acts as a flux, which means to say that it lowers the melting point of those rocks, and so it induces melting. And so you have a different kind of volcano that occurs over here. These stratovolcanoes, arc volcanoes that occur from remelting of the actual crustal material. And that's why they get a different chemistry and why they erupt in a different style. Right? There's Pinatubo, for example, a style of explosive eruption you get from a stratovolcano, compared to what you see in Hawaii, where we mostly have effusive flows. We can still have big ash clouds and collapses, and we've talked about explosions in Kilauea before, right? It can be quite big, but not exactly the same thing, and not for the same reasons as we see at typical stratovolcanoes. Right? And so one more slide is kind of address this issue of why they're so convinced on Tonga, right? And so I'll start off at this end, and we're talking about viscosity and rock type here. So we'll start off with this picture I took from I believe this was off of YouTube, viscosity video, and someone was just pouring different viscosity oils and just seeing how they pile up and flow, right? So you have low viscosity oil over here and high viscosity oil over here. You can just even see from this the way that the the oil is piling up within this beaker and making a surface, it's much flatter here, and it's much steeper and cone-like over here. And of course, this is going to flatten out, right? But this goes to show you that the time scales are different, and the material is actually different, and that's why you have different kind of materials. So, likewise, in volcanoes, when you have low viscosity, you end up with basaltic flows. When you have high viscosity, you end up with rhyolitic flows, and these are the kinds that have that thicker, pastier lava, right? And so the gas bubbles can't just bubble and fly out of it like I see in Kilauea. Kilauea is like a smoke machine; it just kind of puts out gas all the time, right? And when you see a volcano like St. Helens or Pinatubo or other ones like that, they're more like a smoke signal, right? They puff, and another one, and then another one, and then another one, kind of with gaps in between them, right? Because the magma is able to hold the gas until it builds up enough pressure to kind of pop out of there, and it does that in one little burst. And then it kind of repairs its integrity, can hold in the gas once again, and pop. And Kilauea is so fluid, just bubbling out the entire time. And I've described this before as if you take like a glass of water and you stir it, and you're gonna get bubbles get in there, but the bubbles will come up right away and just escape the water. If you do that with a glass of honey, the bubbles will also escape eventually, but it does it a much slower process. The honey is much more viscous than the water, and it can kind of sometimes trap those smaller bubbles beneath its viscous mass, right? If it's like near the bottom, and maybe it's not big enough to actually rise through that medium. So that's why you have different kinds of rocks, right? So when you have low viscosity, you end up with basalts, and if the rock cools underground and it's crystal rich, you call that version of it a gabbro. Whereas a high viscosity rock, that cooling underground forms what you know as a granite. And when that comes out of the ground, it might be a rhyolite as a lava flow, right? So low viscosity, high viscosity, different kind of rocks, different kind of eruptions, a whole different kind of system. And that's really where you can be so confident to say that even though Tonga is really close by to Samoa, it's a totally different kind of volcano. Right now, they certainly can affect each other because, when Tonga erupted, Samoa had to watch out for tsunami, right? When Samoa has an earthquake, then Tonga watches out for tsunami, and so on and so forth. That's really one of the relationships they have, and unfortunately, tsunamis are pretty common there. And I want to kind of end this discussion of Samoa by pointing out this 2009 event, right? So the last time there was a U.S. federal response in Samoa was these massive earthquakes. There was a magnitude 8.1, September 29th, 2009. And within 2 minutes, a pair of 7.8s occurred on a trench itself. Right? So this was catastrophic. Tsunami swept across Samoa, Tonga, much of this area. 192 lives lost. 192. So it was a tragic event. This is coming from Eureka Alert, University of Utah, just to make sure we give credit. And there was an impact to Hawaii, but it was a small tsunami that occurred in Hawaii, resulting from the 2009 huge tsunami, right? So, of course, I'm not going to focus too much on Samoa, but really going to pivot this now to talk about how we can use this as an example for us, right? When earthquakes occur over there, if an earthquake is really close to shore, we don't have as much time to prepare, so it's really important to know what to expect. If you see the water recede, you retreat for high ground immediately. These guys maybe didn't take that advice and thought there was something exciting to see, and maybe regretted that a little bit. It ended up being that dangerous in this particular case, but it could have been. Here's local residents, and this is in Kona, Keaho Boat Harbor, shot by Captain Kurt Bell of the Fairwind. So there are people on a little bit higher ground checking out what's going on. But you can see it's coming and submerging the pier. The fisherman finding himself suddenly knee-deep in water. Parking lot's all flooded. Decided to get out of there. There goes the tourists out of there also, but it's, you can see, maybe not as well planned for. Water retreating off the dock. coming back in. You can see the pier right here in the foreground. And zooming in on this pier, during one of these withdrawals of water, you can see the Zodiac boat tied over here, kind of floating low in the water. And the surge comes back in again. And there's that same Zodiac. And the dock is totally submerged under here now. So you can see the variability. This is a small tsunami for Hawaii. And in Samoa, it was much more destructive. Waves up to 40 feet high, sweeping 3/4 of a mile inland. Just the number of deaths really should convey the scale of the disaster there, right? So it's really a tragic event, and it's, I suppose, perspective of being in Hawaii, it's good to remind ourselves there are other places that have a lot of challenges as well, right? With these natural systems as well. So that's all about Samoa today. We can obviously come back to this further in the future because there's going to be more talk from the USGS. They're going to be issuing daily reports now, right? So instead of having information notices that were kind of one-offs that they can put out as needed, they then put in the volcanic alert notice to be able to switch to having daily updates. So now daily updates will be coming for Taʻu and Ofu-Olosega volcanoes. So we'll be covering those coming up as well. But that is it for now, Dane.
Yeah,
if you want to...
I think the tsunami safety is always, worth reinforcing, because that can happen, even though we kind of have maybe a feel for what's going on here, those earthquakes are always kind of unexpected. And it's not only just us, right? Alaska and Chile can easily send big ones our way and have in our history, right? The last big damaging tsunamis that came through were from there. But we've also, one of the things that this reminded me of was 2011, the Fukushima earthquake in Japan, right? That big big devastating earthquake. Well, hours later, that tsunami arrived in on the island, mostly on Kona side. I remember watching a guy on the Kailua pier running down the pier back and forth, just dodging the stuff. It wasn't like, he was in trouble. He was intentionally going back out there each time, just to run with it. It's like, guys, don't be that guy. Don't be that guy. When the tsunami thing goes off, just go up the hill, stay there for a while. You'll think, this has happened before where people are like, oh, we evacuated. We've been up here for a half hour. When is it over? It can take hours to be over. Right. And just because it looks like it's dying down doesn't mean it won't kick back up in, 30 minutes from now type of thing. So that those tsunami things, we get used to it, but we have a lot of new people coming out, to the islands. And it's like, you guys got to just know this stuff. And for people that grew up out here, it's kind of second nature. But, that's got to be told to people that don't know. Otherwise, they end up, pulling out their camera and, pulling out their cell phone, going up there like, hey, let me get a cool thing of this tsunami. And as soon as you can actually see the tsunami in your cell phone, you've already screwed up, type of thing.
Yeah, the thing is, like, you're going to see the ocean's going to recede. So that's your sign that the tsunami is coming, right? But then the wall of water is going to come building up afterwards. And the thing is, it's going to start building and building. You don't know, like, how much it's going to build. It could build to 5 feet, or it could build to 50 feet. And then suddenly you're looking up at the wall of water, and it's at that point, it's too late. Yeah. There's very few people who actually talk about seeing that view and surviving. People do, right? But they're running the right way or got lucky somewhere or another to escape it, for sure. So that's really the thing you need to know is if you see the ocean retreat and you're by the water, right? Don't wait for like a siren or a warning. Don't go out and collect fish or see what's going on a reef, because you can walk on it all of a sudden. It's turn the other way and tell everyone around you, better safe than sorry, retreat to high ground, right? Because the key is, if an earthquake occurs locally, there are only minutes of time between the actual ground shaking and the waves arriving. The closer you are, it could be a few minutes. If you're like outside that island, it could be 15 minutes, but it's still not more than minutes. So you need to have this embedded in your mind so that that's what you do, right? We really hope that the whole tsunami siren system works. It works really well for these distant earthquakes, right? Coming in when you have hours to prepare and all of that. Excuse me. For the near ones, you may not have that luxury, right? And beyond that, we know that not all the sirens work all the time. So you have to care for yourself as well, right? One last thing I'll share is what Dan was saying as far as the interval and how long it can actually last. This is an analogy that's always stuck with me. Someone described to me like how to imagine an earthquake, and think of an Olympic swimming pool, and you roll a big log into it, and it's going to just slosh all that water around, right? So often fault lines are long and linear also. So when you have like the energy moving, it's like something like a log shape. So when you push a log in, you might get like a bigger splash in one way than to the sides, possibly, but the whole pool is going to start bobbing up and down for a while. And depending on how big the log was you pushed in there, it's going to bobble all over the place for an hour, right? For one pool size thing. So if you have a whole ocean, you have a giant fault that's miles and miles long and it's moving, several meters, and that's what you're basically looking at. So the whole ocean is rippling back and forth, and so you can have a sloshing in and out that takes 15 minutes for it to come in, 15 minutes to go out, 15 minutes for it to come in, 15 minutes to go out. So like that 15 minutes where it's coming out, you're like, oh, okay, everything looks fine, it's going out, it's done. But you're only getting into the, it's like a hurricane. You go see the eye of the storm, you're only halfway through that particular sequence, right? With tsunami, can happen over and over and over again. And so sometimes it is only one major damaging wave, but it could be the second wave or the third wave and not the first one. Sometimes you see 3 in a row that are really damaging. Sometimes you get 4 and none of them are damaging. You just have to be ready, because if you're, it's not like, oh, I'm a good swimmer, I'll be fine. It's not the water that usually drowns you. It's the debris that will knock you in the head and knock you unconscious, like a car, or you smack into a tree, or you get caught in a branch or something. That's the kind of stuff you need to worry about, like hitting a parking pole or a traffic light or something. Like that's, it's the stuff, not the water, right? So
there's all kinds of stuff in that water. I mean,
yeah, that's tsunami PSA.
The smallest, yeah. That water is bad. That tsunami water is don't even go close to that kind of stuff. I mean, people be like, oh, I surf and stuff like that. It's like, it don't matter. Any surfer will tell you it don't matter. Like the tsunami is not a wave, right? It's not a traditional wave that you can ride. You don't even play with those things.
Yeah, if you have to, what you hear happening is if people have time, like if the earthquake's coming from far away and you have hours and hours, right? People go down to the harbor and drive their boats out to sea, because then you can ride it out. You can actually ride the changes without having to be swept on land and off land and on land and off land. Like that's the boundary where it's the messiest. Yeah, so that's where you don't want to be. You're going to be all the way on land or all the way out, like on a boat far away from shore, right? If you need to be.
Right.
Yeah.
Exactly. All right. Well, that gets us through our earthquake stuff and the Samoa stuff as well. We also did talk on the Pohoiki stuff. We're nearing up on 2 hours now.
It's been a long one.
Sorry. Yeah. Appreciate everybody that tuned in today. I know this isn't our normal streaming time. For those that may have caught this, out of sequence, or just this is your first time here, we do normally stream at 5 p.m. Hawaii Standard Time on Thursdays. Unless something happens, like, something along something with the volcanoes or some earthquakes or something like that, then we might go live. Or in the case of yesterday, there's an important public meeting that we're going to live stream, and that conflicts with, our schedule. But otherwise, next week, Thursday, we'll be back, and we'll be going over the latest from Mauna Loa, Kilauea, and we'll be checking out probably Samoa a little bit more often from now on until things quiet down out there.
Yeah, there's going to be more data, and as you guys know, I love data, right? So we'll have data to show, then we'll show it for sure. We'll share it as well. Yeah, and so yeah, as Dana said, thank you guys for sharing your Friday with us. Those of you guys catching us live, we appreciate it. It's not the normal. We won't do it too often if we can help it, but was necessary this week. And we caught up on a bunch of stuff. Mahalo, Dane, for covering last week for me when I was out sick. I am feeling better, obviously. My throat might be giving out a little bit now, but that's because it's been 2 hours.
Yeah.
And yeah, we'll catch up on the things that we weren't able to do this week next week, or in a little more detail and a little more depth, right? We've done enough, obviously, today. A lot to cover and catch up on. So mahalo, everyone.
Yeah, appreciate everybody that stuck with us, through the 2 hour stream. And until next week, this is my aloha.
Yeah, and mine too. So for Hawaii Tracker, he's Dane DuPont. I'm Philip Ong. Aloha, everyone.